The identity function is primitive recursive since it can be written as the first projection of one tuples. The constant function is primitive recursive as an easy induction on the value of the constant shows. Addition, multiplication, and exponentiation are primitive recursive. The details are in the slide. Here we fix a value for 0 up to 0 to have a total function. The predecessor function is primitive recursive. Note how pred of 0 is 0 to have a total function. The difference is primitive recursive. Note how m minus m is 0 when n is less than m. The absolute value of the difference of m and n is primitive recursive. The sine function, which is 0 when the argument is 0 and 1 otherwise, is primitive recursive. Integer division and remainder are primitive recursive operations. The definitions are in the slide. Note how division by 0 is allowed to make the function total. The integer logarithm is primitive recursive. The definition is in the slide. Note how, as before, we force a value even for crazy values of p and m. There are total computable functions which are not primitive recursive. An example is Ackermann's function. It is simple to see that it grows very fast. In fact, it grows faster than any primitive recursive function, although this will not be shown in this course.